po siya. So our topic for today's sorry. So our topic for today's discussion is about wastewater quantity and characteristics. So ito po yung nilalaman ng aming discussion. First is wastewater quantity. So for the wastewater quantity, we have two types. The dry weather flow, or for its acronyms DWF. And for the second one is the stormwater flow, which stands for WWF. The second topic is characteristics of wastewater, and the last is the collection, generation, and transmission of wastewater. So first, we have the wastewater quantity. For the dry weather flow, it is the flow of wastewater in a sewer system during dry weather that presents with minimal infiltration. Sewer systems depend on gravity to ensure that solids and liquids continue on their way to treatment plants. During these dry spells, a sewer drought can occur as the amount of liquid in the sewer is reduced. This reduction in volume ensures a reduction in flow velocity. So for dry weather flow, kadalasan nangyayari ito during summer season, tuwing magkakaroon tayo ng El Nino season, which is sa panahon noon, sobrang init, kaya yung tubig natin sa underneath is mahina lang. And by the help of gravity sa sewer system, nakadepende yung flow niya kung mabagal ba, kung magkakaroon ng minimal infiltration. Tapos kadalasan sa dry weather flow is nagkakaroon siya ng pagkakabitak-bitak dahil sa minsan ang nagagamit na material for the pipe system sa sewer system is mahinang klaseng type of material. Kadalasan sa ginagamit sa pipe system is yung mga iron na material. And for second one, the stormwater. So it is also known as wet weather flow, or the WWF, which flow when rainfall takes place. A part of it infiltrates or percolates into the ground surface, while the remaining flows over the land depending upon permeability of the ground, its surface slope, and many factors. So for stormwater, what do we mean na permeability? Ay yung process na makakapekto sa pag-infiltrate ng tubig sa pipe system natin, sa ating sewer system, sa mga pipeline. Dahil nga sa tag-ulan, sa mga La Nina season, tuwing ngayon, kadalasan ngayong season yon, tag-ulan, is sa ating sewer system, naapektuhan yung pipeline natin, which magkakaroon ng sa ground surface natin kung saan yung pipeline lies within, is nagkakaroon siya ng dito. Yun nga, nagkakaroon siya ng dahil sa surface slope na nangyayari sa pag-agos ng tubig sa ilalim dahil sa tag-ulan is minsan numinipis yung material, minsan numinipis yun sa may pipeline natin. Nagkakaroon ng infiltration. Next. Gaya sabi ko sa dry weather flow. Ayun yung panahon na pang El Nino and tagtuyot. So for this dry weather flow, meron tayong dalawang klase. Domestic or sanitary sewerage and industrial wastewater. For domestic sewage, di ko na papahabain to kasi mahaba yung details. Ang sinasabi lang dito is The principal, sabi nga niya, the principal impurities are protectable organic materials and plant nutrients. But domestic sewage is also very likely to contain disease-causing microbes. Sa domestic sewage ito, kadalasan nagagamit ito sa mga commercial buildings, gaya na dito sa may Eaton Centris, sa may domestic sewage na to, which slightly more than 99.9% yung water by weight. The rest less than 0.1 ay yung mga impurities na ay yung mga hindi na siya na dissolve, ay na yung mga nabubuo. And for that, very small fraction of sewage by weight, nagkakaroon nga ng, ng pagkaroon ng mabigat sa pipeline natin, yung pag-flow sa pipelines natin is mabagal. Kung napapansin nyo sa mga newsfeed natin sa Facebook, kapag may napapanood tayo may inaayos na pipelines, yung akala nyo na mahabang putik na lumalabas sa ating mga tubo, ayun yung sa may domestic sewage natin. Dahil nga sa tagtuyo, kulang ang tubig. Kaya hindi siya, kaya kahit tulungan siya ng gravity is, hindi pa rin sapat yun para maganda yung flow natin. Nagkakaroon siya ng laminar flow sa ating pipeline. Then, next one. For industrial wastewater. Used water from manufacturing or chemical processes usually contains specific and readily identified chemical compounds. So, based sa industrial wastewater naman, dito sa category na to, ito yung mga sewer system wastewater na kadalasan ginagamit sa mga sa industriya, sa mga factory, sa mga oil manufacturing, kung saan gumagamit ng mga chemical compounds na kapag naitapon natin sa sewer system or dumalo siya sa sewer system or nag-infiltrate sa ating mga pipelines is nagkakaroon ng delaying sa flow, nagkakaroon ng laminar flow dahil nga habang nag-flow siya is nagkakaroon siya ng tinatawag natin na friction. Nagkakaroon siya ng friction sa loob ng mga pipeline. Kaya doon kumakapit sa gilid ng ating pipes and so on. Kaya nagkakaroon ng impurities and etc. What are the factors affecting the DWF or the drainage wastewater? The dry weather flow or the quantity of sanitary sewage depends upon the following factors. First, rate of water supply. Second, population growth. Third, type of area served or the nature of industries. And the last one is the infiltration and exfiltration of groundwater. So for rate of water supply, the rate of water supply to a city town is expressed as liters per capita per day. So for the rate of water supply, gumagamit tayo ng unit na liters per capita per day. Kung napapansin natin sa mga about sa business, meron tayong ginagamit na per capita per income, di ba? Para sa ating water supply naman, ito naman, per liters per capita per day. So what do we mean by that is, kung ilan yung nagagamit na liters natin per day, ay yung, kung isa-submit natin yon and for that, ay yung nako-consume ng isang household para sa isang buong araw. So next one is the extra water that enters the sewers can be assumed to approximately equal to the water loss in consumption, etc. Due to this reason, the wastewater flow rate may be assumed equal to the rate of water supply by the municipal authorities. The sewers should be designed for a minimum of 150 liters capita per day. Ayun. So hindi na siya sa household ang tinutukoy sa rate of water supply, kundi sa buong sewer system ng isang livelihood. Nyari sa isang community, meron tayong sewer system doon, nakadesign according sa ating mga sa munisipyo, may mga design na ginawa sa ating mga sewer system or sa mga contractors na bumuo sa isang community or kunyari sa village, subdivision, na bumuo sa isang sewer system nun is nagkakaroon siya ng design na ay na minimum of 150 liters capita per day. What do we mean by that is kunyari sa isang subdivision meron tayong 10 household, nagko-consume siya na minimum of 150 liters per capita per day. Ayun yung nako-consume niya. So, kasama na yun yung sa mga, kunyari nagkaroon tayo ng rainwater, nagkaroon ng stormwater, kasama na rin yung mga infiltration dun. And last, usually the quantity of water entering the sewer will be slightly less than the quantity of water supplied. For practical purposes, it is assumed that the quantity of water which doesn't enter sewer is very nearly equal to the extra quantity of water which enters sewer. In other words, the rate of sewage is assumed as equal to the rate of water supply. The rate of sewage may, however, be assumed lower than the rate of water supply to the extent of about 60 to 70% where there are sufficient reasons to justify such assumption. So for this assumption na quantity of water or the rate of water supply, gaya na sabi ko kanina, kasama na rin dun yung infiltration sa pipeline kapag nagkaroon tayo ng dry season, ay ng wet season or the storm water. Kaya sinasabi dun na the rate of sewage is equal to the rate of water supply na consume. So, etong sinasabi na 60-70% where there are sufficient reasons to justify such assumption is nagkakaroon tayo ng factor of safety para sa magkaroon tayo dito ng maintenance sa ating mga pipelines and sewer system. Next one. Following two factors should be carefully considered while comparing the rate of sewage with rate of water supply. Intensity of pressure. If water is supplied at high pressure, there is more consumption of water and more wastage of water from leakage in pipes, valves, etc. So, there are two, the intensity of pressure and the use of water. So, kung magbibigay tayo na example, sa isang commercial building, kunyari sa Eaton Centris, which alam naman natin na marami doon ang mga BPOs company. Sa bawat building nun, kailangan ng more pressure para may angat yung tubig from sa ating fire system, or sa potable water natin. So for sewer naman, sewage system naman, kung magamit din tayo sa potable water ng high pressure, syempre gagamit din tayo ng high pressure para sa mga sewer. Kasi kapag kunyari, gumamit sa fifth floor, sa kabuuang floor na yan, gumagamit ng 50 liters per capita per day na tubig, na amount of water. So, kailangan natin na taasan yung pressure para umangat yung tubig from basement to fifth floor. Kaya nagkakaroon kaya nalalaman din natin yung rate of water supply kasi nasasama din dun yung mga leakage sa mga pipes natin kasi di naman totally na ayos lahat ng pipelines natin and sa mga valves. Kung yung iba nga may tagas or wala kahit nasa minimal amount din siya na water for less than 5 liters na nasasayang per 3 days or a week. Ayun, kasama na rin siya sa equation natin doon. So for the use of water, the use for which water is consumed should be carefully studied. It is quite likely that water which is supplied may not appear as sewage after its consumption. For instance, water that is supplied to fill up the tanks of railway locomotives will not appear as sewage. Similarly, the quantity of water supplied and the quantity of sewage formed by various prominent industries such as the cotton mills, mill plants, etc. should be studied and accordingly the rate of sewage should be decided. So for the use of water, for the sewage with rate of water supply ng ating, kunyari, sa mga industries na kung saan kailangan gumamit ng maraming tubig. So, kung nagre-recycle tayo ng tubig para maging potable siya, so kailangan din natin na kailangan din natin ma-further study kung ilang rate of kung gaano kalaking rate of water supply ang kailanganin natin para mag-produce sa mga milk plants gaya sa example na to. So para dito kailangan meron tayong study about sa how much can we produce for a total meals, how much can we produce for the a milk in a plant para sa isang araw na production, kasama na dun yung sa break, kasama na din sa mga ginagamit natin sa mga sa mga lavatories and so on. For the population growth, the quantity of sanitary sewage directly depends on the population. As the population increases, the quantity of sanitary sewage also increases. The quantity of water supply is equal to the rate of supply multiplied by the population. Then last, sewage quantity which will be produced in the town due to future developments of the town and population should be taken into account, and as far as possible, accurate results should be obtained. So for population growth, kaya kasama ito sa factors na nakaka-apekto sa ating DWF is because kung gaano karaming tao ang nag-occupy sa isang lugar, ganoon din kalaki dapat or ganoon din dapat karaming tubig ang dapat nating i-supply. So, gaya nga sa equation natin, water supply equals to rate of supply times population. Kung may 10 pamilya na nag-occupy sa isang community, then yung water supply natin is times 10 din dapat, hindi lang times 1. So kung 20 naman, times 20, and so on and so forth. So hindi lang din nagtatapos dahil sa sewage quantity ng isang community, hindi dapat depende yun sa kung ilan lang yung population. Dapat meron din tayong tinatawag na factor of safety, which means na nagkakaroon tayo ng allowance para for the future, para ma-predict natin kung magkaroon ng tayo ng kakulangan sa water supply galing sa ating sewage system. And just as in case of water supply projects, the future population after 2 or 3 decades is determined by applying any suitable method of population forecast. The design period of different parts of the sewerage system is different, and the following factors are taken into account while fixing the probable life of a particular part of the sewerage system. So we have 5 factors: the chances of improvement in the equipment, cost of adding an extra unit of the equipment, labor conditions having important influence on the cost of equipment, maintenance costs and overhead charges, and the operations method. So for gaya nga nasabi ko kanina, hindi lang sa per day yung tinitingnan natin, ina-account natin para sa water supply galing sa ating sewerage system. Dapat ina-account din natin yung mga future population forecast. Kunwari, meron tayong 10 pamilya na nag-occupy sa isang community. What if nagkaroon siya habang tumatagal ang panahon, habang nagdadagdag ng taon is dumadagdag din ng population. So, hindi lang dapat tayo nag-account for 10 families lang or 12 families kung nagkaroon tayo ng factor of safety. Dapat nagkakaroon din tayo ng maintenance kung ilan yung pumapasok na population sa isang lugar, and also yung water supply na kinoconsume doon. So, for that, dapat magkakaroon tayo kino-consider natin yung pag-improve sa mga equipment natin, sa mga pump system, sa ating sewerage system, sa mga yung ginagamit natin na chlorinification, sa mga ginagamit natin sa bar screens para sa mga pagre-reuse ulit ng ating mga tubig na itatapon na sana pero magagamit pa rin. Ayun, so mga labors, and sa cost ng maintenance, which ang pagkakatanda ko nung sa may ODT ko sa Eton Centres, nagkakaroon ng weekly maintenance doon sa bawat building. So, pwede natin i-assume na bi-weekly yung maintenance. So, dapat consider natin yung mga cost nun and mga charges, kung ano yung mga dapat palitan, kung dapat may mga pipeline na gagawin, kung may i-check tayo sa mga equipment natin, kung gumagana ba yung mga pumps natin, and so on. And sa last is the operation methods, kung applicable ba rin ba itong operation na gagamitin natin, kung itong operation ba is masusuffice yung population na meron tayo sa isang community. So usually the design periods of the following parts of sewerage system are: first, laterals. These are designed for 50 years or so. Second, branches and submains. These are also designed to last for 50 years or more. Third, main sewers and trunk sewers. These are designed for 30 to 50 years. Fourth, the pumping plant. As additional pump can be installed with short notice, the design period of pumping plant is about 5 to 10 years. And the last is the treatment units. These are designed for 10 to 30 years. So for the, sinasabi ko kanina, gaya nga na mag-improve tayo ng mga equipments and sa mga pipelines natin, sa mga pipes. So, ito yung mga ito yung mga standard na binigay para sa design na kung hanggang saan lang ang limit nito. Dito natin nililimit kung hanggang kailan natin ito pwedeng gamitin. So, as I read about a report, pwede rin natin sabihin na yung kunyari dito sa laterals natin, laterals in pipelines, laterals is what we connect, kung ano yung kumokonekta sa kunyari sa isang livelihood, kumokonekta sa isang bahay papunta sa ating mga branches, sa bawat branches. Ayun yung parang connecting pipe natin from household to our branches. And the branches and submains ay yung nakakonekta sa bawat laterals natin sa buong community. Na dadalo yon papuntang main sewers and trunk sewers. After the main sewers and trunk sewers, meron tayong pumping plant syempre, kung saan doon natin pinaprocess kung gamitin pa ulit yung mga galing sa sewage system natin. And the treatment units, chlorinification, bar screens, and so on and so forth. Ito yung mga design niya. So, gaya nga na nabasa ko sa report is, kung sinasabi na design for 50 years or so, ito na yung standard, pwede natin sabihin na by 45 years, pwede na natin siyang palitan ulit para mas maganda yung pag-maintain natin sa isang equipment. Dahil kung aabot pa tayo sa 50 years is parang sinasagad na natin yung lifetime ng isang equipment. Kahit na ito yung standard is mas maganda pa rin yung mas sigurado tayo sa gagamitin nating equipment and sa mga pipes and valves and pumps. Next factor is the type of area served or the nature of industries. The quantity of industrial sewage will depend upon the nature of industries. A careful study is therefore made of the industries contributing to the flow of sewage, and the quantity of industrial sewage is then accordingly worked out. Quantity of sanitary sewage also depends on the type of area to be served, whether it is residential, industrial, or commercial. The quantity of sewage produced in residential areas directly depends on the quantity of water supplied to the area. The quantity is obtained by multiplying the population with this factor. The quantity of sewage produced by various industries depends on their various industrial processes, and it is different for each industry. This quantity can be determined by doing a survey that area and collecting the data. So for the type of area served or the nature of industries, we have 3 samples na binigay dito. First is the residential or sa ating mga subdivision, sa village. Second one, the industrial, sa mga factories natin. Third one is the commercial, sa mga fast food restaurants natin. And nga, sa mga community na puro commercial building siya. So, kailangan sa ating sewage system, dapat kino-consider din natin kung saang area tayo nagsiserve. Kung saang area siniserve, kung saang area magsiserve yung ating sewerage system na ating i-design. So, for the residential, alam naman natin na maraming population doon, maraming gagamit, maraming sewers doon na kailangan i-account dahil iba-iba yung paggamit ng bawat bahay. Kaya for that, dapat mataas din yung water supply natin para doon. And so for industrial, kailangan, kunyari, magkakaroon tayo na industry, kunyari sa isang example, ayun na, sinabi natin sa milk plants, kailangan natin magkaroon ng water supply na sufficient lang na para mapanatili yung mapanatili na sterilize yung milk natin na ginagamitan natin ng water, and so kasama na rin dun yung mga laboratories and so on sa mga paglilinis sa mga paglilinis galing sa ating water supply galing sa na reuse na sa sewerage system. And sa last, commercial. Sa commercial naman, sa mga restaurants natin, kung saan kunyari sa isang lugar, nagkaroon tayo ng nakapalibot na commercial buildings, sa SM, yan, kung saan maraming mga commercial stalls, at sa bawat stalls na yun is iba-iba yung sewerage system nila. Merong mga sewerage system na kailangan i-account natin yung mga chemical compounds, merong mga sewerage system na potable water is needed. Meron din mga ibang commercial stalls naman na hindi naman gaano gumagamit ng water supply, pero kailangan natin mag-supply pa rin dahil sa mga necessity gaya ng sa CR, sa mga lababo at sa mga cleanliness na rin. And by that, ito yung sinasabi na dapat na i-consider natin para sa type of area served, natures of industries. So, dito na also additional, para sa type of area served and nature industries, nagkakaroon din tayo ng collection of data sa kung gaano karaming nailalabas sa isang, kunyari sa commercial building, kung gaano karaming nailalabas na sa sewerage system ang isang Jollibee, kung gaano karaming nailalabas ang isang McDo, at kung sa sewerage system, kung gaano naman natin karaming na ibabalik. Kasi kung mas marami yung nailalabas pero kaunti naman yung naibabalik natin, is baka kung ang problema natin is daluyan ng pipe up na galing sa sewerage system na from sewerage system to potable water to our commercial buildings and so on. Last one is the infiltration and exfiltration of groundwater. So for groundwater or subsoil water may infiltrate into the sewers through the leaky joints. Exfiltration is the reverse process which indicated the flow of wastewater from the sewer into the ground. And due to infiltration, the quantity of flow through the sewer increases. Exfiltration results in decrease in the flow and consequent increase in the pollution of groundwater. Both infiltration as well as exfiltration are undesirable and take place due to imperfect joints. Infiltration unnecessarily increases the load on the treatment works. So what do we mean by that na infiltration and exfiltration of groundwater? Infiltration, by the word itself, nagkakaroon tayo ng infiltration sa ating pipelines, na sa ating nagkakaroon tayo ng infiltration sa ating mga pipelines by the groundwater na dumadaloy. And exfiltration, ayun naman yung mga nagkakaroon tayo ng leakage from the sewerage system or ating mga pipelines. Kung nagkakaroon tayo ng mga pagkaroon ng butas, kung merong bang mga joints na hindi connected or not properly mounted, and so forth. Dahil doon naapektuhan yung sewerage system natin. Kung kahit small amount or small portion of water pa rin ang nakakapekto doon is na-account pa rin natin yun through the treatment na gagawin natin, treatment method na gagawin natin. Kung nagkakaroon na ng pagdami ng infiltration, is pwede natin palitan yung pipelines natin. Pwede natin i-check kung meron bang mga butas, mga crack, or mga ruptures. And for the exfiltration, kung marami naman na tumatagas, is pwede natin siyang, kung hindi magagawa ng paraan sa pagtapal, is papalitan yung mga pipelines or magkaroon tayo ng mga valves.
Song. Jason.
Hello?
Ano ba yung mga infiltration? Ano yan?
Sir, sa infiltration, sir, paano nga po, sir, yung...
Ano yung mga, yung mga tubig na sa loob ng tubo? Ano ba yung mga yan? Mga dumi ba yan o ano ba yan?
Sir, sa infiltration po, sir, ito yung kadalasan, kunyari, nagkaroon tayo ng stormwater or nagkaroon tayo ng mga rainy season, sir.
Oh.
Di ba kapag maulan sa ating mga pipelines is galing sa tubig sa ground, bumababa yung tubig, nagkakaroon tayo ng infiltration kung merong butas yung mga pipelines natin. Kaya dahil doon, sumasama yun sa tubig sa loob ng pipelines natin na hindi galing sa sewage system natin. Dahil doon parang nadadagdagan yung na-process natin sa sewage system na kung kunyari, nagkaroon tayo ng 150 na liters na process sa sewage system. Plus the small portion amount of water na galing sa pag-infiltrate galing sa ground surface natin dahil sa
water. Basta anything na nakakapasok sa sa
yes po, sir.
Oh, sige.
And exfiltration ay nga yung reverse, sir.
Naman yun,
opo, sir. Yung tumatapon naman. Ayun nga, gaya na sabi ko kanina, the term infiltration is used to indicate the leakage of water from the ground surrounding the sewer, and the term exfiltration is used to indicate the leakage of sewage from the sewer into the ground. So, ayun. And the last, the infiltration, exfiltration can be prevented to some extent by constructing watertight joint of sewers. The quantity of water through infiltration depends on the following factors: head of subsoil water level, length of sewer. Natanggal sa rin dalawa. And so for the head of subsoil water level, what do we mean by head? Ayun yung elevation head natin or the static head natin. And so the length of sewer, kung gaano kalaba yung pipelines natin from sewer system to our branches and to the laterals. And ayun po yung para sa infiltration and exfiltration of groundwater. Next one is the estimation of stormwater discharge.
Okay po, good evening.
Next reporter, si Alvin.
Apo, sir.
Sige. Ano mo na?
Ayun po, for the next report po, estimation of stormwater discharge po. The peak rate of runoff depends upon various factors such as the type of precipitation, the intensity and duration of rainfall distribution, the soil moisture deficiency, the climatic conditions, the shape, size, and type of catchment area. Then, due to this variable, it does not precisely determine the runoff by exact equation kasi nga po estimation lang po siya ng stormwater discharge nga po. Because in recent years, a rational method has been evolved to estimate the peak drainage discharge. This method can be applied most precisely to areas.
Mo, Alvin. Wala.
And sir, okay na po ulit, sir.
Sabi ko, lakihan yung font, hindi makita, ang liliit. Ano man, dami mong nilalagay. Sabi ko, 6 hanggang 8 lang na line, di ba? 6 hanggang 8. Magtipid sa slide. Kasi presentation niyan kahit 1,000,000 pang slide, pwede yan, no? Maliit kasi hindi mabasa masyado, ha? Susunod, ha?
Okay po, sir. Then, however, for large areas, empirical formulae are used to determine the peak rate of runoff. The most modern method for computing urban stormwater is drainage is by digital computer simulations. Next slide, please. So, for rational method, if a rainfall applied to an impervious surface at a constant rate, the resultant runoff from the surface would finally reach a rate equal to the rainfall. In the beginning, only a certain amount of water will reach the outlet, but after some time, the water will start reaching the outlet from the entire area and the runoff rate would equal to the rate of rainfall. Next is the period after which the entire area will start contributing to the runoff is called the time of concentration. Next is it is the time required by the water to reach the outlet from most remote point of the drainage area. Next one is the runoff resulting from a rain having a duration lesser than the time of concentration will not be maximum as the entire area will start contributing to runoff in this case. Next slide, please. Next slide, please. Thank you. So, based upon these principles, the rational formula was developed by the efforts of American. This formula states that the QP equals 1 over 36 multiplied by K multiplied by PC multiplied A, where QP is the peak rate of runoff in Qmix, and K is the coefficient of runoff. PC is the critical rainfall intensity during the critical rainfall direction, and A is for the catchment area contributing the runoff at the considered point in hectare. Next slide. Next slide. So, for the coefficient of runoff, is in fact the impervious factor of runoff, representing the ratio of runoff to precipitation. The value of K increases as the imperviousness of the area increases. For perfectly impervious area, K. Ito, may table po tayo para sa value ng K for solving. Ayan lang. Naka-state na dyan kung saan surface and yung value po ng K. Then hanggang next slide. Hanggang dito po sa next slide, ganun din po yung mga value rin po ng K. Next slide. For empirical formulae, for the design of drains having catchment area larger than 400 hectares, it is generally advisable to use the empirical formula suggested for the region. Various empirical formulae for calculating stormwater runoff have been suggested by various investigators. If the important formulae are given below is the list of the formula. Next slide. Here's the sample problem for the stormwater discharge. In a district area, 40 hectares, the density of population is 300 persons per hectare, and the quota of water supply is 225, and 20% of the area consists of brook with runoff ratio is 0.80. Maximum rainfall intensity is 5 cm per hour. Calculate the quantity of sewage for which the sewers of a separate system should be designed, and stormwater for which the sewers of partially separate system should be designed. So next slide. So ito yung sa solution para dun sa case 1. Total area of the district is 40 hectares. Then next is the population density niya is 40 multiplied by 300 equals to 12,000 persons. And average water supply is equal siya sa 225 liters per capita per day. The average quantity of water required supplied to the district per day is multiplied natin siya sa population density multiplied by average water supplies which is equals to 2,700 cubic meter per day. And the rate water supplied is 2,700 over 2,400 multiplied by 60 multiplied by 60 is equals to 0.03125 cubics. Next slide, please. And this another problem is assuming the sewage discharge as 0.8 times the water supplied. Average rate of sewage produced 0.8 multiplied by 0.03125 equals 0.025 cubics. Now, assuming the peak rate of sewage as 3 times the average, peak rate of flow is 3 times multiplied by 0.025 equals 0.075. Next slide. And for the case number 2, in case of particularly separate system, the stormwater from roofs and paved yards of house will be allowed to enter the sewers. So area of roofs equals to 20 multiplied by 40 over 100 equals 8 hectares. The value of the K is 0.9 and area of paved yards equals 5 over 100 multiplied by 40 equals 2 hectares. The value of K is 0.80. The discharge from roofs and paved yards of house is given by rational formula QP equals 1 over 36 multiplied by K multiplied by PC and multiplied by 8. And substitute all the values, we get the QP equals 1.22 cubics. Hence, the term water which pass through the sewers of a partially separate system is 1.22 cubics. That's all.
Hello po. So, just to illustrate po, good evening po sir. So, next naman po natin is yung characteristics of wastewater. Wastewater is used water that has been affected by domestic, industrial, and commercial use. The composition of all wastewaters...
Sino to? Si Alvi pa rin ba yan? Alvi? Ikaw ba
De Los
yan?
Reyes, sir.
De Los Reyes. Pakilakas mo yung
Apo.
ano ha? Pakilapit mo sa mic.
Pinamala, sir eh.
Yan na ba?
Apo.
Sige, sige. Okay.
Sir, nahiya lang yan, sir. Nahiya lang yan.
Di, sir.
Lakasan mo. Kasi hindi marinig eh.
Sige po. So, ulit sir. So, yung next na report po is characteristics of wastewater. So, wastewater is used water that has been affected by domestic, industrial, and commercial use. The composition of all wastewaters is thus completely changing and highly variable, which is why it is so difficult to pinpoint a singular definition of the word itself. Because of the different chemicals for both industrial and commercial household uses, it causes the wastewater to be constantly changing in terms of its properties. Characteristics of wastewater can be classified into 3, which is the physical properties, chemical properties, and biological properties. So, next. Next song. So first is the physical properties of wastewater, which is the color of the wastewater itself. Fresh domestic sewage is gray, somewhat resembling a weak solution of soap. With the passage of time, as petrification starts, petrification ito yung pagdidecay, it begins to get black. The color of the septic sewage is more or less black or dark in color. So the color of industrial wastewater depends upon the chemical process used in the industries. Industrial wastewater will mix with domestic sewage may also add color to it. So next is the temperature change. Generally, the temperature of wastewater is higher than that of water supply due to addition of warm water from households and from industries. When wastewater flows in closed circuit, its temperature rises further. So this results in the increase in the viscosity of water and also increase in its bacterial activity. Next. So next is turbidity. Turbidity is a measure of light-emitting properties of wastewater, and the turbidity test is used to indicate the quality of waste discharge with respect to its colloidal matter. To measure the turbidity of a certain water, nephelometric turbidity unit or NTU is created, or the nephelometric method. It works by emitting light through the sample. The higher the NTU, the cloudier the water is. And the lower the NTU, the clearer it is as the picture indicated. Yan po. Ito po yung sample ng
Ano yung
NTU test.
sinasabi mo? NTU? MTU? Ano sabi mo?
Nephelometric turbidity test.
Okay.
Yan po yung nag-shine po ng light, sir, sa mga sample na yan, sir. So kapag mas mataas po yung value ng NTU natin.
Pag malinaw, ano ba yan? Pag malinaw,
pag malinaw po, mas mababa po yung
mababa.
NTU.
Pag malabo,
mataas po yung NTU.
Yun ang turbid, no? Mas
yes, po.
ano. Okay.
Yes po, sir. So, next naman po. Next is suspended solids. These are the insoluble solids suspended in a liquid and visible to the naked eye. So as the picture indicated po, ito po, nakaturo naman yung suspended solid na nakikita natin sa pinakataas. We see in the top is the suspended solids or the particles that we can see in our naked eye. So yan po, yung mga solid na hindi natutunaw or hindi hindi natutunaw. So next. Next po is yung chemical properties ng wastewater natin. Wastewater contains of chemical in various forms. So, as shown below po. So, first is the chemical oxidation demand or COD. This is the measure of the amount of organic matter in wastewater based on oxygen required to oxidize it. Next is nitrogen. It is measured in its different form, nitrate, nitrite, ammonia, and organic nitrogen. Next is phosphorus. It is generally measured in its mineral and organic form, total phosphorus. Next is chlorine, sulfates, and heavy metal. So ito lang po yung mga example ng ibang chemical na nakikita natin sa wastewater.
Sa wastewater, next, matatagpuan yung mga yan sa wastewater?
Yes po, sir.
Okay.
Next naman. Next naman po is yung sa biological properties or the microorganism that can live on wastewater. Domestic sewage, by its nature, contains enormous quantities of microorganisms. The biological characteristics of sewage are related to the presence of this microorganism. A microorganism that requires living tissues to grow is called a pathogen, and is a parasite which must depend upon the host organism as a proper environment for growth and reproduction. So, and it can be classified in three categories such as aquatic plants, aquatic animals, and aquatic bacteria or virus. So, next is, ito po yung example ng mga aquatic plants na makikita natin sa mga wastewater. So, spermatophyta or water weeds, Birophyta, mosses or leverworts, Pteridophyta, ferns and horsetails, Talophyta or algae. Next po is yung mga aquatic animals naman. Meron mga vertebrae, muscula, arthropoda, worms, metazoa, and protozoa. Lastly po is yung aquatic molds and bacteria naman. So meron tayong mga fungi, mga viruses, at mga bacteria na nakita sa ating mga wastewater. Yun lang po.
So, generation of wastewater. Wastewater comes from domestic and residential sources, including bathing, flushing the toilet, doing laundry, and washing dishes. Commercial wastewater originates from non-domestic sources such as beauty parlors, taxidermy, furniture restoration, music instrument, washing facilities, and car body shops. Hazardous elements could be present in this effluent, necessitating specific handling or disposal. Next. Type of residential wastewater treatment. So there are two types of residential wastewater treatment. First is lagoon system, which places the wastewater in a shallow pool. Then treated effluent from the lagoon is introduced into the environment through slow evaporation. Second is the septic system, which places in an underground tank treated effluent from the tank, then introduced into the environment through a drain field. Next. Two categories of wastewater. So the first one is gray water, usually comes from the shower, bath, washing machine, tubs, and other than kitchen sink. Black water comes from toilets and kitchen sinks. Collection of wastewater. System for collecting spent water from residential and non-residential users and transferring the flow to the wastewater treatment facility include gravity pipes, manholes, tanks, lift stations, control structures, and force mains. This effluent must be collected along thousands of miles of pipeline before it can be processed and released back into the environment. Transmission of wastewater. Microorganisms are used in wastewater treatment systems to break down raw sewage. These bacteria eventually die from oxygen shortage after fulfilling their function. Countless dead bacteria accumulate at the bottom of storage tanks, forming a thick biofilm sludge. Inside the water tank, sludge builds up and needs to be cleaned frequently for good operation. Sludge can fill up water tanks if it is not cleansed, making a wastewater treatment facility ineffective for handling new trash. Sludge is necessary consequence of purifying the water that is used by every member of a community prior to being released into the environment again. Wastewater needs to be cleaned, otherwise, one of the most valuable resources for the environment, water, will run out in the cities. Furthermore, the sludge ends up in a landfill it is not reused.